The history of seismic data onshore spans far more than 100 years. It's a story not just about the technology, but also about the people behind the technology. So while we could start many centuries earlier, we start this story a little more than 100 years ago during World War I. Thanks to the likes of Andrew McNaughton, William Sansom, Lawrence Bragg, Reginald Fessenden and Luda Mintrop, acoustics emerged as a method of remote sensing. Mintrop had developed a portable seismic detection system to locate Allied artillery for the German army, while Karcher did almost exactly the same thing for the Allies. The first reflection patent was filed in 1929 by Karcher, much later than his first successful experiment. Onshore seismic acquisition has two important components, the source and the receiver. All early seismic data was recorded with high explosives as a source. And these were not small explosions. And when the surface didn't permit drilling deep holes, shallow patterns of explosives were used. This advert's from the 1950s, so for the first 25 years no other source was used. Dynamite is still being used today, but in 1953 the weight drop technique was introduced as an alternative to dynamite. Remarkably, this has its origins in tests conducted in 1907 by Mintrop, who dropped a 4-ton metal sphere from a derrick as a source. The first weight drop trucks used a 3-ton weight dropped from about 10 feet to thump the ground. The system evolved through different techniques to accelerate the weight faster, so-called accelerated weight drop systems. These included using a large elastic band. Modern systems use electromagnetic or hydraulic acceleration techniques. Shown here are a fleet of on-size electromagnetic thumpers from SAE and a hydraulically driven thumper from Polaris. At the same time, in the early 50s, Conoco introduced Vibrosize. Conoco geophysicists Crawford, Doty and Lee received the SEG Medal Award, now known as the Reginald Fessenden Award, as original patent holders and developers of Vibrosize. Vibrosize units evolved into the units we see today on most seismic crews. This advert comes from the early 60s, less than a decade after Vibrosize was first introduced. And the units of the 60s are a far cry from today's Vibrosize units. Today we see the modern Vibrosize units working in all environments, from the frozen north to the tundra to desert and urban areas, with many units on a single crew. At the other end of the ray path, we have the detector. Luckily, we have better methods than this to detect sound waves that come up from the subsurface. But of course, instruments were also required not only to detect the sound, but also to record the seismic data. And early systems were bulky. The system shown here is from 1927. Crews grew slowly from one man, one detector and a truck, to multiple detectors and trucks, and then to multiple detectors from a single truck. And by the early 30s, the back of a recording truck was capable of recording data from half a dozen detectors. By the 1950s, recording systems had reached a channel count of 24. This is a control panel for a single channel. 24 identical control panels would have been used for a 24-channel system. And in the late 1970s, recording stretched to nearly 100 channels at a time. Note the roll-along box on this Sercel system, which allowed the observer to connect to 96 channels out of twice this number that might be deployed. At the same time, the detectors themselves were inexorably shrinking in size and changing in method from the moving arm geophone to the coil geophone that we know today. By 1950, use of the moving armature geophone was in decline, but was by no means a museum piece in the early 50s. 10 years later, in the 60s, it was a museum piece. The image on the right compares a geophone of the 1930s with one of the 1960s, which looks very much like the coil geophone of today. Today, many of the detectors use even smaller technology of MEMS, and the future suggests even smaller spatial sampling may be possible. Fiber optic detectors, distributed acoustic systems, or DAS, offer the potential to move back to analog sampling, but now a spatially analog system. At this point, it's interesting to look at the number of channels that could be deployed on a land seismic crew. I start this chart in 1970, since this is the year that Moore made a prediction about technology development, which others have applied to different technology. The number of channels on a seismic crew from the early 70s until today does indeed seem to follow the log-linear relationship that Moore suggested. But let's look backward from the 70s. If this trend had held to earlier years, we might have expected that the first single-channel recording would not have happened until the early 50s. But we know the line goes back to 1921 and Karcher's original experiment. So what happened in the 1960s? This was the dawn of the digital age. Up until then, all recording, regardless of how it was done, had been analog. The change to digital recording fundamentally changed what was possible. Channel counts went from 2 to around 24 in the 1950s to hundreds, and then thousands, and then tens of thousands. 3D acquisition became possible. The concept of 3D seismic acquisition has been around for a long time. The advert on the left is from 1947, but the first 3D onshore seismic acquisition was not conducted until 1972. It involved 500,000 traces. Acquisition took a month. Today, some seismic crews record an equivalent number of traces in less than 30 seconds. In 1928, there were 4 land crews working in the US, but in the years 1941 to 45, all but one of the 22 new oil fields discovered in the US had been found using the seismic reflection method. The number of crews had increased enormously. The early increase in seismic crews could not be maintained. And while we saw another peak around the early 80s associated with the price of oil, since then there's been a steady decline in the number of active land crews in the US. Today, they number no more than there were 10 years after Karcher's first experiment. One of the most important technical developments that led to this digital revolution was the invention of the monolithic integrated circuit chip by Robert Noyce and Jack Kilby in 1959, while Jack was working at Texas Instruments. Noyce and Gordon Moore of Moore's Law subsequently founded Intel in 1968. But we should look at this corporate history as the technology is intertwined with geophysics. In 1925, Karcher formed a new company, Geophysical Research Corp., GRC, which is now part of Sercel. Seismic reflection was so much better than refraction, and in 1930, geophysical servicing was quietly established to make the method available as a service to the oil and gas industry. Later, in 1941, the company was purchased by McDermott, Green, Johnson and Peacock. 3 of these men, along with Karcher, were destined to subsequently become SEG presidents. In 1951, the company was renamed Texas Instruments, with GSI as a division. GSI went through a number of corporate transactions, some of which are shown here, and it now resides inside Schlumberger. Through a similar set of corporate transactions, Mintrop's original seismic refraction company, Seismos, has also ended up inside Schlumberger. This corporate history is interesting only because none of these companies are involved in land acquisition today. So we started with some of the greats of the last 100 years and looked at others along the way, but I wonder if any of these innovators could have predicted today's technology, sometimes using local ingenuity to overcome a problem, and on other occasions developing new vehicles for difficult terrain. But perhaps these innovations are best exemplified by comparing Karcher's recording system of 100 years ago with one of today. Originally taking half a dozen men to carry a small number of geophones through swamp in the 1930s, I wonder if Karcher could have conceived of moving equipment by helicopter, or of a single man deploying 100 full recording systems with survey through GPS, detector and recording, all in the palm of your hand. Would he have thought that exactly 50 years later, and 50 years ago today, man would conduct the first active seismic experiment on the moon? And so, as man was planting geophones on the moon, IAGC was formed. And as we move forward, perhaps we will not even have a single man in the field. 100 years ago, Karcher recorded a couple of traces. Tomorrow, we'll be recording 1 million for every shot we take.